Given the following example, we want to find the limit as x goes to 1.5. So in this case, we have a function that's defined by some condition. Okay, so we need to get rid of the absolute value. Okay, the first thing that we need to do first is that we don't want to divide by 0. So that's why we need to find the domain. The domain is the set of all those values. Domain is x in R such that 2x minus 3 different from 0. That means it's x in R such that x is different from 3 over 2. Okay, that means it's R minus 1.5 or 3 over 2. So we have the function defined for all the values except when x is 1.5. In fact, when x is 1.5, we have 0 in the denominator. So we don't want to divide by 0. That's why we get rid of this. So now the question is asking us to find the limit at this particular point. Okay, so we're gonna write this one nicely because we wanna get rid of the absolute value. So by definition, the absolute value of 2x minus 3 is 2x minus 3 if 2x minus 3 is positive. Okay, that means when x is bigger than 1.5, we just add a 3 to both sides and we divide by 2 to get this one. Okay, 2x minus 3 is minus 2x plus 3 if x is less than 1.5. We are not including the x equals 1.5 because it would make 0. So that's why we have to get rid of it. So in this case, we have two functions. Okay, we can write f as 2x squared minus 3x over 2x minus 3 if x is bigger than 1.5. Also, f of x is 2x squared minus 3x over minus 2x plus 3 if x is less than 1.5. Okay, we can also simplify this one. We can rewrite it here in this first case and in this second case. So in the first case, f of x can be written as, if we factor by x, we get x 2x minus 3 over 2x minus 3. Since this one is never 0, we get just x. In the second case, we have f of x is equal to, if we factor out by minus x, we get 2x, or let's keep the minus, let's factor out by the minus x. So we have minus 2x plus 3 over minus 2x plus 3. And since this one never 0, we get minus x. That means we have f of x defined by the following. So f of x is x when x is bigger than 1.5 and minus x when x is less than 1.5. Okay, so in this case, finding the limit would be different. Okay, so the limit from the right and the limit from the left. So the limit from the right is this one. The limit from the, okay, let's write it here. So x is 1.5. So when x is bigger than 1.5, which one is that? So here, that means we have x. When x is less than 1.5, we have minus x. So when x is bigger than 1.5, we can think of the limit as from the right. We get to x to 1.5 from the right. So here we have the limit of f of x as x goes to 1.5 from the right. So we use this function. That means x is just 1.5. we get closer and closer to x, which is 1.5 in this case. The limit of f of x as x goes to 1.5 from the left, which is when x is less than 0.5. So we have minus x. That means minus 1.5. Okay? So that's what we have. So we have two different limits. Therefore, there is no limit at this point. Okay? The idea is we can rewrite our function in such a manner that we have two different functions. Okay? One is defined when x is bigger than 1.5. One is defined when x is less than 1.5. Okay? We can also graph this function to see what's happening. Okay. Anyways, the good thing is to be able to see what's the limit from the right and what's the limit from the left. So the limit from the right, when x is bigger than 1.5, you have this function, which is x. And the limit from the left, you have this function when x is less than 1.5. And we can just compute the limits. Okay? And this ends our video.